Let's talk about MEGA software. MEGA stands for Molecular Evolution. Start by going to megasoftware.net. This is the home page that you will come to. And as you can see in the middle of the screen, you have the option to download. That's the only way that you can run MEGA software is to actually download it. But the good news is it runs across multiple platforms, as well as once your data is input into the software, you can run the software without the internet. If you scroll to the bottom of the home page of MEGA, there are a lot of useful information links that you can click on, such as tutorials, like videos, walkthroughs, articles and features, frequently answered questions, and they also besides being able to use MEGA software to look at distance, diversity, um, phylogeny, bootstrapping, and all of the evolutionary tools that they have, you can also look at disease mutation and you can look at it as far as likelihood and distance. Once you've downloaded the MEGA software, this is what the home page looks like. And we're going to talk about alignment. So if you look at the top left, you see the button that says Align. The first thing that you want to do is click Align. Once you click Align, this is the menu that comes up underneath Alignment. And what you want to do is click Do Blast Search. This brings you to the BLAST page at NCBI. And this is where you put your query sequence, or what we would call your accession number, or you can even paste part of any FASTA DNA sequence that you have. And this is where BLAST will try to match your sequence to find homologs. Under Choose Search Set, you can choose to look at the human genome only, the mouse genome, or you can choose other organisms. And so you have a variety of different ways that you can search. You also have program selection, and that looks for sequences that are only highly similar, more dissimilar, or somewhat similar. Somewhat similar is usually a good choice here. And then you can click on at the very bottom, there is a tab for algorithm parameters. Once you click algorithm parameters, the only thing that you really need to change here would be max target sequences. I believe this is automatically set at 100, which is a pretty low number. So 5,000 is a fair number to start with, and that may change depending on what you are looking at. And after you do that, you click BLAST to begin your search. Once your BLAST search results pops up in a few minutes, this is what that page will look like. And this shows you a lot of valuable information that you will use. So it shows your query length, which in this case was 449. It also, if you look down below above the graph, it shows you that how many sequences match this query. So in this case, the number was 992. On the results page, if you scroll down beneath the graph, this actually shows all of the hits that match your query. So this is where your important information is. So you have your description, max score and total score. Those are not very helpful because those are all dependent on the length of the query and on the sequence length. So what you really want to look at is query cover and e-value. Query coverage is very important. That shows how much of the query region matched the chromosome. And then the e-value, that's the number of matches that you'll find that match by chance alone given a query of this length and of this size. This first one says there is no probability of it not being a homolog, so it's exactly the same as the query. What you need to do is find the description that you want to choose. You click that, and that takes you to the alignment. Once you click on your description, the page that you find will look something like this. And what you want to do next is click on the link that says GenBank. Once you've clicked the GenBank link, this is what your page will look like on NCBI. And what you want to do here is scroll down to the bottom and click Sequence Link ID. Now you want to save your session. And now these sequences are not aligned, but you want to go ahead and save what you have already. Once you save your session, right below that it says Export Alignment. You want to click that and save it in the Mega format. The reason for that is because you want to save it within Mega to be able to utilize all of the tools that Mega offers. Once you click to save in the Mega format, you can name your file. One automatically will pop up for you, but you can save it any way that you choose. And as you can see, the file type, it's saved as .meg, which is the Mega file format. One of the tools that Mega software has is the Mutation Explorer, which I briefly mentioned at the start. And I input the CHD7 gene information, and when you go into the Mutation Explorer, that is what this looks like, and it shows your gene name, peptide ID, gene product, and then you can click on Diagnose Variant. Here's an example of Mega's disparity index test. So again, I chose the CHD7 gene for humans as well as 3 different other organisms, and it shows you the disparity index to the right side of the screen compared to each other. Here is also an example of what pairwise distances would look like within Mega. Again, I used the same CHD7 gene with human and 3 other organisms that were the same from the previous slide, and you can see the pairwise distances among those organisms for that particular gene. Mega gives you the tools to look at evolution within organisms in a variety of different ways. This is an example of the evolutionary relationship of the 4 taxa that were in the previous 2 slides with the same CHD7 gene. So it can actually show you the relationships based off of a gene, not just off of the organisms and their entire genomes. So that's very cool. This is what a time tree or phylogenetic tree would look like. This organism is Crotalus, which is the genus for rattlesnakes. One of my favorite organisms, and probably not some of yours. But this is very cool because evolutionary-wise, it breaks out each individual species and shows you their relationship over time. Using the data from the previous slide, you can even go and dive further into the evolution of organisms within Mega. For instance, with Crotalus, this shows the divergent times. So this shows the periods and eras and how they have evolved over time. And if you look to the left, it even shows climate change charts. And you can look at your O2 levels, your CO2 levels, earth impacts, and then obviously it has your geological time scale. This is just a super cool tool when you are looking at different organisms and their relationship over time.